So these are our guided notes for Math 0 to 3, radical expressions and radical operations with radicals. Also radical equations will be covered in the later sections. This is the last module for Math 0 to 3. And a radical expression is any expression containing one or more expressions in the following format. And the radical is here. We have our radical symbol. And it's read the nth root of a. And the expression the nth root of a is equal to b if and only if a is equal to b to the nth power. So kind of think of it as the inverse of a power. It's figuring out, what they did to the number to get, or like what number you would multiply together however many times the index is to get the answer. So for example, the cubed root of 8, which is right here, equals 2 because 2 to the third power equals 8. So I call it kind of like the check mark with the tail, or the symbol in the expression is called your radical. The A in the expression, or the number underneath the radical, is called the radicand. Let's see there. The N in the expression is called the index. And we are probably most familiar with the square root. And in that case, we don't always see it. So if n equals 2, the expression is written as just the radical with the number underneath, and it's called a square root. And if n equals 3, then it is also called a cube root. So what we're going to do here is we're going to evaluate or simplify each of the following without a calculator. And we're going to assume that all the variables represent non-negative numbers. So what we're going to be dealing with here are going to be what we call our perfect, either square roots or cubed roots or roots. And that means that the solution to them will always be a whole number. So it won't be a decimal or part, made up of parts of whole numbers. It will be always a whole number. So the square root of 16, I want you to think to yourself, what number squared will give you 16? And that will be the square root of 16. And in that case, the answer is 4, because 4 times 4 gives me 16. And that is called a perfect square because your answer is a whole number. The square root of 144. So again, we're asking ourselves what number squared or multiplied together twice will give me 144. And our answer is 12. The square root of 144 is 12. Now for C, we have a number and then a variable. So we'll look at two separate things. First, we're going to find the square root of 81. So what number multiplied together twice will give me 81? And that equals 9. And then we want the square root of x to the 6th power. And really what we do here is I'm going to write the 2 in, because you want to figure out how many groups of x squared is in under the radical if you have x to the 6th power. So if I were to write it out just to show you how we get it, I'm going to put 6 x's under here. All right, and one set here I can pull out. I have another set of x squared and a third set. So there are 3 sets of x squared under the radical. So this is going to equal x cubed. Another way to find it is to take the 2 and divide it into your exponent. So 2 into 6 is 3. So my answer to this problem, I'll draw a little arrow down here, would be 9x to the 3rd power. All right, for D, the square root of 49 is 7. And again, my index is a 2. If it helps you, write it in. You don't have to. We'll divide 2 into 12 to figure out how many groups of 2 x's I have. and 2 goes into 12 6 times, so it'll be 7x to the 6th power. And then 2 goes into 16 8 times, so y to the 8th. So my answer is 7x to the 6th power, y to the 8th. So now here we're looking at our cubed roots. So now instead of saying, well, what number do I multiply together twice to get the answer? It's what number do I multiply together 3 times to get, in this case, 27. So now we're looking for a number cubed that will give me 27. So think of it like that. We're looking for the cubed root or the root of the problem. What is that number we multiply together 3 times? And in this case, it happens to be 3. So our answer is 3, because 3 times 3 times 3 will give me 27. All right, now for F, we have the cubed root of negative 125. So we need to know what number multiplied together 3 times will give me negative 125. Now, if you recall, and we won't see it in this math class, but under a square root, you can't have a negative number, because if I do like negative 4 squared, it's negative 4 times negative 4 gives me a positive 16. But if you have an odd index, like here we have a 3, it's an odd number. If I multiply a negative number together 3 times, like for instance, if I did negative 2 times negative 2 times negative 2, 2 negatives make a positive, but when I multiply that positive answer times my last negative, I get a negative number. So you can have a negative under an odd radical, but you can't have a negative under an even index. So if it was a square root or a fourth root, you have to have a positive number, not a negative, but the cubed root you can. And the cubed root of negative 125 is going to be negative 5, because negative 5 times 5 times 5, or negative 5 times negative 5 times negative 5, will give me negative 125. All right, for G, again, we have a number and a variable. So we're going to divide our index into our variable, again, just like we did with our square roots. The cubed root of 64 is going to be 4, because 4 times 4 times 4 will give me 64. And 3 will divide into 12 4 times, so it'll be x to the 4th. And again, what you're doing really is you're figuring out underneath that radical, if I draw out 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 x's. We want to figure out how many groups of 3 is under there. And if you look, there are 4 groups of 3. So it's x to the 4th power. All right, our last one here on this slide is the cubed root of negative 216, x to the 18th, y to the 24th. The cubed root of negative 216 is going to end up being negative 6. And then 3 goes into 18 6 times, so we'll have x to the 6th power. And 3 goes into 24 8 times, so y to the 8th power. And that's our final answer. Now, if you're having a hard time finding your answers here, or you're like, how does she know that? Sometimes, and we'll do this later on, but it's easy. I make a list. So I make a list of 1 cubed equals 1, because 1 times 1 times 1 is 1. 2 cubed equals 8. 3 cubed equals 27. 4 cubed equals 64. And the more you see it, the better off you'll get. But if you want to make that list, go ahead. All right, so here we're going to look at different indexes other than the square or the cubed root. We're going to start off with our 4th root of 81. So again, I'm asking myself, what number, if I multiply it together 4 times, will give me 81? And in this case, it happens to be 3, because if I do 3 cubed is 27. 27 times 3 will also give me 81. Next, we want the 5th root of 32. So what multiplied together 5 times will give me 32. And typically when we look for the 5th or the 6th root for us, we're not going to get too big. We're going to either be looking at like 2 or 3. We're not going to make you go really large numbers. And in this case, it is 2, because 2 times 2 times 2 times 2 times 2 will give me 32. Now for k, again, we're doing the same thing. The 4th root of 16 is 2. And now we divide the 4 into my power. So 4 goes into 12 3 times. So there are 3 groups of 4 underneath the radical that I can pull out. And 4 goes into 20 5 times, so it'll be y to the 5th. All right, and our last one for this section is going to be the 6th root of 64, x to the 36th, y to the 6th. The 6th root of 64 is 2. 6 goes into 36 6 times, so it will be x to the 6th. And 6 goes into 6 once, so I can pull out one group of 6, or one y. So my answer is 2x to the 6th y. Okay, so here they ask us to approximate the following radicals accurate to 3 decimal places. And each of these radicals are not perfect squares, so their answers will not come out to be whole numbers. And any number that is not a perfect square or a perfect cubed root, 4th root, is always going to end up being an irrational number, which means that it is a decimal that never repeats in a pattern and never ends, similar to pi. So here you're getting the approximate answer because you can't find the complete answer because you can't find, how far it out goes. It goes on infinitely. But for our first one, I'm going to type it into my calculator. I'm going to do the square root of 30. And I hit enter. And I get 5. I'm going to write some of what I get. I get 5.4772255575. That's everything my calculator gave me. Obviously, it can't end there, but that's as far as my calculator will go. And they want us to estimate it accurate to 3 decimal places. So here I'll round, and because that is a 2, I'll leave my 7. So my answer is 5.477. Next, I will do the cubed root of 96. And to get there on your graphing calculator, you want to do math, and then you'll notice option 4 is a cubed root, and type in 96 and hit enter. So again, I get 4.57885697, but I only want 3 decimal places. Now my 8 is my last number there, and because that is an 8 as well, I'm going to round up. So my answer will be 4.579. And then our last one is the 4th root of 2048. So again, I'll go back to math. Now there isn't an option for a 4th root, but if you press 5, you can type in your index and then type in our 2048, and I get 6.727171322, and again to 3 decimal places. So there's a 1 next to my 7, so my answer is going to be 6.727. And if you're not sure how to use your calculator, I will create another YouTube video for you guys where I show you the calculator and how to use it, so that way you know for sure. So look for that video as well. So the next section that we're looking at is rational exponents. And a rational exponent is an expression that contains a fractional exponent. And a rational exponent can be written as a radical using one of the following forms. So if you have an exponent that is a fraction, so a to the m divided by n, you can write it as a to the mth power, and you're looking for the nth root. So what you're doing is your denominator is always going to be the index of your radical. The numerator is always the power. And there's 2 ways to write it. You can write it with the exponent with the radicand underneath, or you can put it on the outside. And I'll show you both ways. I think it's sometimes easier to put it on the outside, but that's my personal opinion, and so it's up to you. So our first one we have is 4 to the 3/2 power. And for that one, if I write it as a radical, I'm going to need my radical here. The big number, the 4, goes underneath. Now remember, your power, or your numerator, is your power that goes with it. So it'll be 4 to the 3rd power, and I want to find the square root of that. Okay, so that's one way to look at it. I can find 4 to the 3rd power, which I know is 4 times 4 times 4. And from our previous section, I also know that that is 64. So I'll take the square root of that and I get 8. Or I could have done it this way. I could have done the square root of 4 and then cube it, which I think is sometimes a little bit easier. And the square root of 4 is 2, and 2 cubed will give us 8. So we got the same answer. I just did it a couple different ways. Now for B, it's 16 to the 3/4 power. So if I write it under the radical, my 16 will go underneath. And then 3 is the power and 4 is the root. And let's see, 16 to the 3rd power is 4,096. That's 4,096. And we're looking for the 4th root of that. And that is something where, now it says evaluate without a calculator. They want you to write it out. But if you don't know the 4th root of 4,096, you can use a calculator to find that. That's not one that I have memorized, so I'm going to use my calculator, put the 4th and 4,096, and I get 8. Now, if I had written it the other way, and I did the 4th root of 16, and then I cubed it, the 4th root of 16 is 2, and 2 cubed gives me 8. So it's a little bit easier, I think, to do it that way. So for 27, I'm going to do it that way. I'm going to take it, and my power of my radicand, I'm going to put on the outside of the parentheses. So I'll put 27 on the inside. It's a square root. You don't have to write the 2 in, but I think it's easier. I'm going to write it in. So we'll do the square root, or no, excuse me, I'm putting it in the wrong spot. That should be a 3 there, not a 2. Let me erase that because it's 2/3. So let me fix that. That should be a 3 there. And then we'll square it when we're done because that's the power, the numerator. The cubed root of 27 is 3. And then when we square it, we get 9. So my answer is 9 there. So here we still have a fraction for our exponent, but now it's also negative. So the first thing I'm going to do is make it a positive by writing it as 1 over 9 to the 1/2 power. Because remember, flip it to make that exponent positive. And then I'll write it in radical form. So I'll have 1 over, and it's going to be the square root of 9. And then because my power is 1, I could put the 1 there, but I don't have to. I'll show you it that, but we don't really need it. And then your square root of 9 is 3, so our answer is 1/3. All right, we'll do the same thing for E. So we're going to do 1 over 8 to the 2/3 power. And the first thing I'm going to do is write it as a radical so I can simplify it. So I'll have 1 over the cubed root of 8, and then that will be squared. So it's going to give me 1 over the cubed root of 8 is 2, and then we'll square it. So my final answer will be 1/4. All right, so here they just want us to approximate the following rational exponents accurate to 3 decimal places. So really, they want us to type it into the calculator and find the answer. So I'm going to type in 7, and then to do an exponent of a fraction, I'm going to do the caret button, which remember is under your clear button. And then I'll do parentheses and 2 divided by 3, and that'll put my fraction in there. And then hit enter, and I get 3.65930571. but they want 3 decimal places. So this is a 3 right here. So I have a 9 here, but a 3 there. So my answer will be 3.659. Next, I'm going to do 65 to the 3/5 power. So I'll type in 65, do the caret, which again is found right under the clear. And then in parentheses, put 3 divided by 5, because that'll give me that fraction. And when I do that, I get 2.3, and we'll round it to 3 places. There's a 9 there again, but that's a 0, so we'll leave it a 9. So I have 12.239, or 239 thousandths. And then my last one, first thing I'm going to do to save me some work, I'm going to make it into a positive exponent. So I'm going to make it 1 over 113 to the 2/7 power. And then I'll type it in. I'll do 113. And then again, my caret, and then 2 divided by 7 in parentheses. And I get 3 point, now this is going to be 1 over, I'm going to round it, 3.86, and then it's 0, 0. So it'll be like this. And then I'm going to do just 1 divided by 3.86 to get my final answer. And it's going to give me, because I don't want to leave it with a decimal there, so I get 0.259, and then it's 0.6, so it'll be 0.259. So now we're going to simplify some expressions and write our answer as a radical. And this is where you're probably like, why do we need to know rational exponents? But here, when we multiply, which we're going to talk more about in a later section, we can only multiply like radicals with the same index. So here I have the square root of x cubed times the cubed root of x squared. So I don't have the same index, so I can't just multiply them together. However, if I write them in exponential form, so I'm going to take this and it's going to be x. So remember, my index is a 2 if I don't see it. My power is 3, so that's the numerator. So it's x to the 3/2 power times, and then I'm going to have x to the 2/3 power. Make that a 3. Let me fix that for you guys. Okay. Now what I can do, if you recall, when you multiply powers with like bases, you add your exponents. So what I'm going to do is I'm going to take my 3/2 and add my 2/3. Don't forget, you need a common denominator. So my common denominator is going to be 6. So that means I multiplied this by 3. I'll multiply this up here by 3. So I get 9/6. 6 there. 2/3, I multiplied this by 2, so I'll multiply that by 2, and I get 4. So I have 9/6 plus 4/6, which is going to equal x, because I'll keep that, to the 13/6 power. And then the final thing is they want you to write it as a radical, so we're just going to take this out of exponential form and put it in radical form. Remember, your denominator is always your index. So that's the number outside the radical. And then your numerator is your power. So we have x to the 13th on the inside, and my index is 6. So it's the 6th root of x to the 13th. We're going to do the same thing with b. I'm going to start by writing them in exponential form. So I will have y to the 3. I can't get this 3 to work. To the y to the 3/4 power times y to the 2/5 power. And again, I have to add my fractions, so I'll do 3/4 plus 2/5. And my common denominator will be 20. So 4 times 5, so I'll do 3 times 5 will give me 15 on the top. 5 times 4, and I'll do 2 times 4, give me 8 here. So 15 plus 8 will give me 23 over 20. So this will equal, again, we add our exponents, so y to the 23rd over 20 power. And the last thing we have to do is write it as a radical. So my denominator is my index. So we'll have the 20th root of y to the 23rd power. And that's all we're going to do. We're going to leave it just like that because that's what they want. So here now what we're doing is we're dividing radicals. And again, when you divide them, you have to have that like radicand, or not radicand, but index. And we don't. We have a square root and a cubed root. So remember, when we divide powers, we subtract exponents. So I'm going to put them in exponential form first. So this here will equal, I'm going to write it down here, but it's going to be x to the 1/2 power minus x to the 1/3 power. Again, if you don't see that power, it's always that 1 that's there. And if you don't see an index, it's a 2. So again, I'm going to subtract my fractions. I need to have a common denominator. So I have 1/2 minus 1/3. So my denominator is going to be 6. And I'm going to multiply by 3, So I get 3/6. I'm going to multiply by 2 and 2. So 3/6 minus 2/6 is going to give me 1/6. So my answer is going to be x to the 1/6 power. But if we write it in radical form like they want, my index will be 6, and it'll be x to the 1st power. You can put the 1 there, but you don't need to. All right, and our last one for this section is going to be z to the 3/4 power minus z to the 5/8 power. And again, we'll subtract our fractions because we subtract our exponents. And what we're going to get is going to be 3/4 minus 5/8. My common denominator will be 8. So I'll multiply by 2, multiply by 2. So we get 6/8 minus 5/8. So I get 1/8. And when I write it as a radical, it will be z under the radical. My index will be 8. And it's to the 1st power. So this will be my final answer. So here what we're doing is we're going to look at the product and quotient rules of radicals. And again, we talked about this earlier in the other section. When we want to multiply or divide radicals, they have to have the same index. And if they have the same index, then I can multiply them together and put them under one radical. Same thing with dividing. Now with division, if it's under one radical and it's easier, you can split it up and put it under 2 radicals, because sometimes then you can do a little bit of simplifying. So we'll look at it that way as well. So here I have the square root of 7 times the square root of 3. And because they both are square roots, I can rewrite them under one radical. And it will give me my final answer of the square root of 21. And that's really simplified as much as I can. I'm not going to turn it into a decimal. It's not a perfect square, so I'll leave it like that. Most of the time, if it's not a perfect square, they want you to leave it under the radical because that's considered your exact answer. Again, if you turn it into a decimal, it never ends and it never repeats in a pattern, so that's your approximate answer. And then see, for B, we're looking for the cubed root here. So I'll do the cubed root of 9 times 3. So when I multiply that, it's going to give me the cubed root of 27. And that one we know is a perfect cube, so I can simplify it to a final answer of 3. And then my last one for this slide, we're going to do the square root of 2x times the square root of 8x cubed. So I'll put it all under one radical. And then we're going to do the work under the radical. So 2 times 8 is 16. X times x cubed. Remember, we're multiplying with powers, so we add our exponents. We get x to the 4th. And then this one, again, we can simplify it. The square root of 16 is 4. And again, if we divide that 2 into the 4, it goes in twice, so it will be x squared there. So we're going to keep continuing with multiplying or dividing under the radical. And now we have the 4th root. So we're going to do, I'm going to write it as one radical. So we have the 4th root of a b to the 5th times 2b to the 11th. And when we multiply underneath that radical, 8 times 2 is 16. B to the 6th times b to the 11th will give me b to the 16th because we add those exponents. And then I can simplify it. The 4th root of 16 is 2. And the 4th root of b to the 16th will be b to the 4th because 4 goes into 16 4 times. So that one we're done. Now for e, I can't divide x by 125. So underneath that radical, I can't do anything with it. But like we saw on the other slide, I can split it up. So I can do the cubed root of x divided by the cubed root of 125. And now I can simplify as much as I can. The cubed root of 125 we know is 5. So I'll just leave the top because I can't do anything with it. So I've simplified it as much as possible. I took the cubed root of what I could. All right, and then for f, I'm going to divide it up again. I'm going to make it the 4th root of y to the 12th over the 4th root of 81. And with both of these, I can actually simplify them. The 4th root of y to the 12th is going to equal y to the 3rd, because 4 goes into 12 3 times. And then the 4th root of 81 is 3. So my final answer is y cubed over 3. All right, so the next section that we're going to look at is how to simplify radical expressions. And this is a section where we talked about having perfect squares, and that's what we've been dealing with so far, or perfect cubes or perfect roots. But not all radicals are going to be perfect. And like I said, we could use a calculator to evaluate them, but then we're going to get an irrational number, a decimal that never ends and repeats in a pattern. So just kind of like simplifying fractions, you can simplify radicals, but what you do is you're going to pull out the perfect squares from the number. So if you look here, the square root of 8, it's not a perfect square. I can't find 2 whole numbers that I can multiply together to give me 8. But I can break it down under the radical as 4 times 2. Because those are 2 factors of 8 that when multiplied together give me 8. And it just so happens that 4 is a perfect square. So I can take the square root of 4 and get 2, and then leave the number, the 2, that isn't a perfect square under the radical. So I can break it down into 2 square root 2. The next one for b, we have the cubed root of 14. Now before, when we divided 3, or our index, into our variables, the powers, they always went in evenly. But they don't always do that. So here, I know that 3 goes into 14, and I can divide it up into 3 goes into 12 4 whole times. So that makes it x to the 4th. But then I have a remainder of 2. So I always think with these, with the variables, I'm doing a division problem. And we'll see how many times 3 will go into 14 4 whole times. And then when you subtract there, you have a remainder of 2. Your whole number, that's your exponent on the variable on the outside of the radical. And your remainder remains with the variable underneath the radical still. And I talked earlier as well about having just the charts to help you remember the numbers. Here they give you a brief chart that's good to have. Hopefully you've already made your list so you have it with you. But 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100. Then we have 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216, 7 cubed is 343, 8 cubed is 512, 9 cubed is 729. Oops, I fixed that. That would be 729. And 10 cubed is 1,000. And I always say it's good to keep this list and add more if you find them, if you need to. The fourth roots, 1 to the 4th power is 1. 2 to the 4th power is 16. 3 to the 4th power is 81. 4 to the 4th power is 256. And 5 to the 4th power is 625. So we're going to start simplifying each radical expression. And they don't want a decimal equivalent. They want you to keep it under the radical and give the exact answer, but pull out any perfect squares that you may have. So we're looking for the square root of 20. So I want you to think about your factors of 20. Like, what can you multiply together to get 20? And I know, of course, I can do 20 and 1, but that doesn't help me. I can do 2 and 10. But 2 or 10, they're both not perfect squares, or neither of them are. But I can also do 4 and 5. And what you want to look at is go back to that perfect squares list. 4 and 5 has a perfect square in it. 4 is a perfect square. So what I can do is I can take this and break it down into the square root of 4 times the square root of 5. And then the square root of 4 is equal to the whole number 2. So that comes out under the radical. And because the square root of 5 isn't a perfect square, we'll just leave it. So it'll be 2 square root 5. All right, do the same thing here with 75. The square root of 75 is not a perfect square. But think about your factors of 75. We can break it down into the square root of 25 times the square root of 3. And the square root of 25 is 5, the whole number 5, so I can bring that out from under the radical, and then we'll leave our square root of 3. All right, now 8, or C, we saw 8 already. We know that we can break it down as the square root of 4 times the square root of 2. And then I'm also going to deal with my x to the 5th power. So the square root of 4 is 2. I'm going to leave a little bit of space there. Then under the radical, we'll leave the other 2 because it's not a perfect square. And then here with my variables, 2 divides into 5. And I'm just going to write it here. 2 whole times. 2 times 2 is 4. So when I subtract, my remainder is 1. So remember, that means that the x that comes out is going to have a 2 because 2 goes into 5 2 whole times. And your remainder will tell you how many x's you'll have under the radical still. Because my remainder is 1, I have x to the 1st power, or just x under the radical. So my answer will be 2x squared times the square root of 2x. So now for D, we're looking at the square root of 32, x to the 7th, y to the 9th. Let's take a look at the square root of 32 first. For 32, I want to go through the factors of it. We know we can do 1 and 32, but that won't help me. I can do 2 and 16, and then also 4 and 8. And the reason I listed them out this time is I want to show you, a lot of people with 32 think, oh, 4 and 8 will work. But we can break down the square root of 4 as 2, but then we can break down 8 further, so you'd have to do more work. You want to get the highest perfect square that will go into it. So 16 and 2 is the better one to use. Now, if you did 4 and 8, that's fine, but you just have to remember, we just broke down 8. We have to break that down as well as getting the square root of the 4 there. So we're going to do down here the square root of 16 times the square root of 2 times the square root of x to the 7th, and then the square root of y to the 9th. So it's kind of jumbled together. So the square root of 16 is 4. Then I am going to leave some space, and I'm going to put my square root of 2 over here. Remember, x to the 7th, 2 goes into 7 3 whole times. So I'll bring out x to the 3rd power. And then, if I'd show you down here, 2 goes into 7 3 whole times. We subtract 6, we get a remainder of 1. So I am going to leave under the radical an x there. And then 2 for the y's goes into 9 4 times. So I'll have 4 whole times. So I'll have y to the 4th on the outside and 1y left over on the inside. And that's kind of sloppy, so let me rewrite it. I'm going to erase it just so I can rewrite it for you guys neatly. All right, so we had 4 x to the 3rd, y to the 4th, and then underneath the radical we had 2x and y. All right, so that is our final answer there. Right now for E, we are going to look for the cubed root of 40. So now we're going to work with our perfect cubes. So we want to think, like if we look at our factors of 40, 1 and 40, but that won't help us, 2 and 20. We can do 4 and 10, or 5 and 8. But now we want perfect cubes. 4 is a perfect square, but it's not a perfect cube. However, if we look at 5 and 8, 8 is your perfect cube. Because now we're going to do the cubed root of 8 times the cubed root of 5. The cubed root of 8 is 2, and then we'll leave the cubed root of 5 under the radical because we can't do anything with it. And our last one for this slide, we have the cubed root of 54. With 54, I know that I can do 2 times 27, and I happen to know that 27 is a perfect cube. So we'll do the cubed root of 27 times the cubed root of 2. The cubed root of 27 is 3, so we'll have 3. The cubed root of 2 is not perfect, so we're going to leave it under the radical. So it'll be 3 times the cubed root of 2. So our final two that we're going to work on simplifying are both cubed roots again. So now we have the cubed root of 216. And this one's kind of nice because the cubed root of 216, that is a perfect cube. That is 6. So right away, I'm going to turn that into a positive 6. But I still have to deal with the cubed root of x to the 16th. And here, remember, divide that 3 into 16. So if I write it down here, right, 3 goes into 16 5 whole times, and 3 times 5 is 15. So we have a remainder of 1. So that means I'm going to have 6. I'm going to bring out x to the 5th power, but then underneath my radical, I'm still going to have 1x left over. So it'll be 6x to the 5th times the cubed root of x. All right, now h, a little bit more difficult, only because 250, it's not a perfect cube. So I have to break it down. And again, look at your perfect cubes. You have 1, You have 8, 27, 64, 125, and see which of those go into 250. And I happen to know that we could do 250 times 2. Or not 250, excuse me, 125 times 2 to get 250. So I'm going to break it down into the cubed root of 125 times the cubed root of 2. The cubed root of 125 is 5. And then I still have to deal with my variables. So I have x to the 7th and y to the 30th. 3 goes into 7 2 whole times. So I'm going to bring out x squared. And then underneath that radical, I'm still going to have my 2 from up above. And I'm going to have 1x left over. I have a remainder of 1. Now 3 goes into 30 10 whole times with no remainder. So that will just be right here, y to the 10th on the outside. And that's it. And then the only thing I want to caution you guys is make sure you look and your index goes with your radical so you don't think it's an exponent. So our next section, we are going to add and subtract radical expressions. And it's kind of like combining like terms we did before. In order to have like radicals, you have to have the same index and the same radicand. So you have to have the same index and the same radicand. Your like radicals may be added or subtracted by combining, again, like terms. And in some instances, if you have unlike radicals, you can combine them by first factoring the radicals so that they are the same. So again, simplifying those radicals. All right, so we're going to take a look here. And for A, I have 7 square root 2 plus the 4th root of 5 plus the square root of 2 plus 14 4th root 5. So I want to find all my like terms and add them together. I have 7 square root 2 and then the square root of 2. So those are like terms. I can add them together. Now, remember, if you don't see anything in front of a radical, just like any variable, it has that invisible 1. And what you do is you add the coefficient or the number in front of the radical. So 7 square root 2 plus 1 square root 2 would be 8. And you keep the radical. So I have 8 square root 2 plus, and then if I go to red here, I have the 4th root of 5. And I have 2 of those. They are like terms. So I will add them together. And again, I have that invisible 1 right there. 1 plus 14 will give me 15. And it will just keep the 4th root of 5 there. And that's it. That's all we can do unless we multiply it out and get decimals. But we don't want to do that. We want to leave it as simplest as possible. So we've combined our like terms. We're done. All right, let's take a look at B and find our like terms. They all have the radicand of 5, but if you notice, my indexes are different. I have the cubed root of 5, and then I also have the 4th root of 5. So 2 different sets of like terms. We'll do our cubed root of 5 first. So it's 7, and then minus 8, because you keep the sign with a term. So that's going to give me a negative 1 cubed root of 5. And you don't really have to put the negative 1 there. You can just put negative cubed root 5. And then my 4th roots of 5, it's negative 10 minus 14. So it's going to give me negative 24 4th root of 5. And that will be your final answer. All right, so here for C, right now we do not have any radicals that are like, so I can't add them together as they are. But the square root of 18, we can simplify that because there is a perfect square in there. If you remember, 18, I can break it down. I can do the square root of 9 times the square root of 2. So when we started off, it was 2 square root of 18. So I have this. I have 2 times the square root of 9 times the square root of 2. I'm going to turn the square root of 9 into 3, because that's what it is, and then keep my square root 2. So 2 square root 18 will simplify to 6 square root 2. And then we still have our 5 square root 2 here. But now my indexes are the same, so I can add them together, and I get 11 square root 2 is my final answer. All right, D is going to take a little bit more work. So the square root of 20, I can break down. So I have 7. And then remember, 20, we can do the square root of 4 times the square root of 5. So the square root of 4 is 2. So that's going to change into, and I'm going to write it down here, 14 square root 5. The square root of 45, I'll do 6 times the square root of 9 times the square root of 5. And the square root of 9 is 3. So 6 times 3 will give me 18 square root 5. And then 5 square root 5, it is in simplest form. I can't do anything with it. And the nice thing is now they've all simplified to the square root of 5. So I will add them together. 14 plus 18 plus 5 will give me 37. And we'll just keep our square root 5. All right, so again with E, both my radicals not like, so I can't really do anything with it right now. But the square root of 27, again, I can break that down. So I'm going to have 4 times, and I know I can do the square root of 9 times the square root of 3. So it would be 4, the square root of 9 is 3, and I'll keep my square root 3 because I can't do anything with that. So I'm going to end up with 12 square root 3 here. And then 12, we'll keep our negative 8. We can break that down to the square root of 4 times the square root of 3. So I'm going to have negative 8 times 2, because that's the square root of 4, times the square root of 3. So we'll get minus 16 square root 3. And it gave us the same radical, so we can do 12 minus 16, which is negative 4. And we'll keep our square root 3. All right, F, again, we got to break it down. 32, we did that one already. Remember, we'll keep our 3 in front. And 32, we're going to do the square root of 16 times the square root of 2. And we will get 3 times 4 times the square root of 2. So it's going to give me 12 square root 2. I'll keep my minus sign there. Now we have 2, 18. We just broke it down earlier. It's going to be times the square root of 9 times the square root of 2. So that will give me 2 times the square root of 9, which is 3, square root 2. So that will be 6 square root 2. And then 128, it can be broken down, I want to say, I think 128, if we divide it by 2 is, yes, 64. So we have, I'm going to keep my minus sign, 6 times the square root of 64 times the square root of 2. And I just tried 64 because I knew it's the square root of 8. And so we'll have 6 times the square root of 64 is 8 times the square root of 2. 6 times 8 is 48. So we'll have 48 square root 2. And then I will combine my like terms. So we have 12 minus 6 minus 48, and that's going to give us negative 42, and we'll keep our square root 2. Now we're going to look at multiplying radicals. And again, when we multiply radicals, we do have to have a common index. So here they both have the square root. So we are going to distribute the 2 square root 5 to each of my terms in my binomial. So when I do 2 square root 5 times the square root of 3, I want you to think like it's 2 times that invisible 1 on the outside. So I'll keep the 2, and then we'll multiply under the radical, and we'll do 5 times 3. So it will be 2 square root 15. And then when we do 2 square root 5 times negative 6, again, I'm going to multiply the numbers outside the radical, which will give me a negative 12. And then there aren't any other radicals, so I'll just tack that square root 5 on because it's really times the negative 12. And then if I can, I will simplify, but 2 square root 15 minus 12 square root 5, I can't do any simplifying with it. The radicals can't be simplified, so we're good there. Let's look at B. We have 4 square root 3 times the square root of 6 minus the square root of 3. So again, we're going to distribute. And 4 square root 3 times the square root of 6. Remember, I think there's that 1 there. So 1 times 4 is 4. 3 times 6 will give me the square root of 18. And we'll keep it under the radical for now. Minus, and then 4 times 1, again, is 4. The square root of 3 times the square root of 3 will give me the square root of 9. And then this one we can simplify. We want to break it down as much as possible. So remember, the square root of 18, we will have the square root of 9 times the square root of 2. And that will give me 4 times the square root of 9 is 3 times the square root of 2. So we'll make it 12 square root 2. And then keep our minus sign. Now, the square root of 9 is 3. So we're going to end up with 4 times 3 there, and it'll be minus 12. And we have to stop there because 12 square root 2 minus 12, I can't subtract my 12s because they're not like terms. This one has a square root of 2. This one has nothing. So it's like, you know, our term with the radical and then our constant term without. So we're done. It's simplified as much as we can do. Okay, so here we're going to multiply 2 binomials together. So really what we're going to be doing is kind of like our FOIL property. We'll start off, we'll do our first terms. So the square root of 2 times the square root of 7 will give me the square root of 14. Then I'll do the square root of 2 times the negative square root of 5. So it'll be minus the square root of 10. And then we'll do our inner terms. So the square root of 3 times the square root of 7. And it's a negative square root 3. So it'll be negative square root 21. And then our last terms, 2 negatives make a positive, and it'll be the square root of 15. And then you want to simplify if you can, but none of my radicals here have perfect squares in them. So that's all I can do. I don't have any like terms to add. I don't have any radicals to simplify. So this right here, this whole thing is my final answer. All right, and then for D, we are going to do the square root of x times the square root of x, which will give me the square root of x squared. That doesn't look good. Let me fix that for us. So it is the square root of x squared. Then we will have plus the square root of 5x. And then minus the square root of 5x. And then a negative times a positive will give me a negative square root of 25. And we can do some simplifying here. My middle terms, I have plus 5x minus, well, plus the square root of 5x minus the square root of 5x. So they will cancel out. The square root of x squared, remember 2 divides into 2 one time, so we get x. And we'll keep our minus sign. The square root of 25 is 5. So my final answer there will be x minus 5. All right, so now with these, remember when you square an expression, you have to write it out and FOIL it. So really we're going to have the square root of 2 minus x times the square root of 2 minus x. And we'll start off with FOIL. So the square root of 2 times the square root of 2, give me the square root of 4. I'll simplify it later. The square root of 2 times a negative x will give me negative x square root 2, because you want to try to put the variable that's outside the radical or the number first. And then here, inside we'll have negative x square root 2. And our last terms, negative x times negative x will give me positive x squared. So when I simplify this, the square root of 4 is 2. Negative 1x minus negative 1x, or 1x to square root 2. They're like terms here, so it's going to give me negative 2x square root 2, because I had 2 negative x's, square root 2's, and then plus x squared. And none of them are like terms, so I really can't do anything else with it. So that part is done. All right, and our last one where we're going to multiply, we have 3 square root of 5 plus 4 square root of 2 times 3 square root of 5 plus 4 square root of 2. So first terms, 3 times 3 is 9. The square root of 5 times the square root of 5 will give me the square root of 25. Then 3 times 4 square root 2. 3 times 4 is 12. The square root of 5 times the square root of 2 is 10. Inner terms, 4 square root 2 plus 3 square root 5 will give me again 12. Square root 10. And my last terms, 4 times 4 is 16. The square root of 2 times the square root of 2 is the square root of 4. And now we need to simplify. The square root of 25 is 5. So I'll end up with 9 times 5 there, or 45. Then if you add 12 square root 10 plus 12 square root 10, because they have the same index, you get 24 square root 10. And then here, 16 square root of 4 is 2, so 16 times 2 is 32. And the last thing we can do is the 45 and the 32, they're numbers, we can add them together. They're like terms. So we would end up with 77 plus 24 square root 10. All right, so one of our next to the last sections that we're going to do is solving radical equations. When you solve a radical equation, first you have to isolate the radical to one side of the equation. So you just want the radical to be on one side, everything else to be on the other side. So once you isolate the radical, then you're going to raise both sides to the power of the index. So if it's a square root, you'd square both sides. If it's a cubed root, you multiply both sides by the power of 3. The fourth root, you'd multiply both sides to the power of 4, and so on. And then finally, after you do that, you'll get rid of the radical, then you'll solve the equation, and you do want to check again for those extraneous roots, anything that won't work. Because sometimes when you solve it to a power or raise it to a power, you get an extraneous root in there. So you just want to check your answers to make sure they work in the original equation. All right, so for our first one, for A, it's nice because our radical is already isolated. I have the square root of 2x plus 6 under the radical, nothing else there, and it equals 4. So because my index is 2, what I'm going to do is I'm going to end up squaring both sides. So I'm going to raise both sides to the power of 2. And when you raise or you square a square root, you end up with just what's under the radical. So you're going to get 2x plus 6. And then 4 squared is going to equal 16. So now it's a linear equation. We just solve it. We're going to start by subtracting 6 from both sides. And I'll end up with 2x equals 10. Divide both sides by 2, and x equals 5. Now the last thing you want to do is check it. And you want to see if I do 2 times 5. So instead of 2x, I'll do 2 times 5 plus 6. Will that give me a 4? 2 times 5 is 10, plus 6 will give me the square root of 16. And when I take the square root of 16, I do get 4. So my answer is x equals 5. It does work. All right, let's take a look at B. And the radical isn't by itself. We have that minus 4 there. So the first thing I'm going to do is just add 4 to both sides to move it over. So then I'll end up with the square root of 3x plus 3 is equal to 12. Now my radical is isolated. There's nothing else there. So I'll square both sides because that's my index. And again, when you square a square root, you end up with what's under the radical. So we'll end up with 3x plus 3. 12 squared is 144. And a linear equation again, solve it. I'll subtract 3 from both sides. So I have 3x equals 141. Divide both sides by 3. And when I do that, I get x equals, it does go in evenly, 47 times. And then when I do the math to check it, it does work. So I get 8 as the solution if I do 3 times 47 plus 3, take the square root of that, and then subtract 4. So it is a solution.
So for C, it's the cubed root of 4x minus 1 equals negative 2. And if we notice, the radical is already isolated. So we're going to start off, and instead of, we don't have to isolate anything. Instead of squaring it, because it's a cubed root, we're going to cube both sides. So when I do that, when you cube a cubed root, you get what's under the radical. So I'll have 4x minus 1. And then when you cube negative 2, you get negative 8. And then solve from there. So I'll add 1 to both sides. And that will leave me with 4x equals negative 7. Divide by 4. And x equals negative 7/4. Well, if you plug it back into the equation to show that it works, if I did the cubed root of 4 times negative 7/4 minus 1, your 4's here, when you multiply, will cancel. So you have negative 7 minus 1, which will give me the cubed root of negative 8, which equals negative 2. So it does work. All right, for D, we do need to isolate the radical. So we're going to start off by subtracting 4 from both sides. And I will have the 4th root of 2x minus 6 equals 2. Then we'll raise everything to the 4th power to get rid of the radical. So if you raise the 4th root to the 4th power, you get what's under the radical. So you get 2x minus 6. And then 2 to the 4th power, equals 16. And now we're going to solve it. I will add 6 to both sides. So I will get 2x equals 22. Divide by 2, so x equals 11. And if we try it, 2 times 11 is 22. 22, I'm looking up here, minus 6 will give me 16. The fourth root of 16 is 2. 2 plus 4 equals 6. So it does work. Okay, now E, again, we want to isolate that radical. So I'm going to subtract 7 from both sides. And I will end up with the square root of 4x minus 8 equals a negative 2. And I'm going to square both sides to get rid of the radical. So I'll have 4x minus 8 equals 4. Add 8 to both sides. So I get 4x equals 12. Divide by 4. X equals 3. Now when I plug it back in and I try it up here, we're going to do 4 times 3 minus 8 plus 7 and see if we get 5. 4 times 3 is 12. 12 minus 8 is 4. The square root of 4 plus 7 is 2 plus 7. It gives me 9, not 5. So even though x equals 3 solved my equation, it is not. It's an extraneous solution to the equation. So for us, because it doesn't equal 5 when we plug it back in, we're going to say no solution because the 3 does not work. All right, now for F. We're going to isolate the radical by first adding x to both sides. So we will have the square root of 4 minus x equals x minus 2. And I just put it in that order because it'll be easier. Now we have to square both sides. So under the radical, we'll have 4 minus x. But now on this side, we're squaring an expression. So we're going to do x minus 2 times x minus 2. So that will give us 4 minus x on the left. And we'll have x squared minus 2x minus 2x plus 4. We'll simplify it. So we have 4 minus x equals x squared minus 4x plus 4. Now it's a quadratic, so it's to the second power, so we have to factor it. We have to make it equal to 0 first. So I'll subtract 4 from both sides. Negative x equals x squared minus 4x, and the 4's will cancel. And then I'll add x to both sides. So we get x squared minus 3x. And then we'll make it equal to 0. We'll factor it. I'm going to move up here. So we will have x times x minus 3 equals 0. So we'll get x equals 0 when we set it to our factors to 0. And x minus 3 equals 0. So we'll add 3 to both sides. And we get x equals 3. So my two solutions right now are x equals 0 and 3. Let's test them out. So 4 minus 0, we go to blue so we can see it. 4 minus 0 is 4. So the square root of 4 is 2 minus 0. Doesn't equal a negative 2, it equals a positive 2. So 0 won't work. We plug in 3, 4 minus 3 minus another 3. So we'll get the square root of 1 minus 3. That will equal our negative 2. So we're good there. So 3 is our only solution. 0 is extraneous. It doesn't work. So our last section that we're going to look at with radicals is the application of radical equations. And the first thing we're going to look at is our Pythagorean Theorem. And we use this for right triangles. And it states that if you have legs A and B and hypotenuse C, The relationship between the legs and the hypotenuse is defined as a squared plus b squared equals c squared. Now your hypotenuse is always c squared, and it is the longest side. The legs make up the right triangle. So on this, there's a leg here, and here's a leg. They're always, connected to that right triangle symbol, which you see down there. And the hypotenuse is always opposite that right triangle symbol. So let's find x. And if we start with our first one, they give us a leg. So we'll say a squared is 5.2 squared plus x squared equals 11.6 squared. And when we do the math, 5.2 squared equals 27 400ths plus x squared equals 11.6 squared equals 134.56. Now we want x squared by itself, so I'll subtract 27 400ths from both sides. So we get, when we do that, x squared equals 107 5200ths. But I want x, not x squared. So to unsquare something, we take the square root. So the square root of 107.52. Now I'm going to round it to the nearest thousandth spot. So it's going to be x equals 10.369. All right, let's take a look at B. And here's our right angle. So again, we have one leg and the hypotenuse. So we're going to do 5 squared plus x squared equals 13 squared. And if we square it, 25 plus x squared equals 169. Subtract 25 from both sides. So we get x squared equals 144. Take the square root of both sides, and x equals 12 this time. Our next application with radical equations is the distance formula. And the distance formula will give us the distance between two ordered pairs on the coordinate plane. And your formula is d is equal to the square root of x2 minus x1, which are just subscripts to differentiate between the two x variables. So you subtract them and you square them, plus the y variables subtracted and squared. So let's find the distance between 0, 3 and 3, 7. And I'm just going to label them. It doesn't matter which one you call x1 and y1, as long as x1 and y1 are together and x2 and y2 are together. So I'll plug them in to d equals, and we will do 3 minus 0 squared plus 7 minus 3 squared. So we'll get d equals 3 minus 0 is 3. So we have 3 squared. 7 minus 3 is 4 squared. So that will be 9 plus 16 equals the distance. And that will be the square root of 25, which equals 5. So they're 5 units apart. All right, let's try B. I'm going to call this x1, y1, x2, y2. So we'll say D is equal to 1 minus a negative 10 squared plus 50 minus a negative 10 squared. So D equals, you want to simplify under that radical first. 1 minus negative 10 plus a positive there, so you get 11 squared plus 60 squared. So we get D equals the square root of 121 plus 3600. And so that's going to be D equals the square root of 3,721. And when we do that, our answer equals a whole number of 61. So they are 61 units apart. All right, our last two problems for this section is brought to us by Heron's formula. And Heron's formula can be used to find the area of any triangle as long as you're given the lengths of the sides of the triangle. And the formula is A equals the square root of S times S minus A times S minus B times S minus C, where S is half of the perimeter. And the formula to find that is here. So you add up all three sides divided by 2. So we're going to start off here with our triangle. We have sides 10, 26, and 24. So first we need to find S by doing 10 plus 26 plus 24 and divide it by 2. So 10 plus 26 plus 24 equals 60. And 60 divided by 2 equals 30. So S equals 30. So I'll plug it into my formula. And we're going to have A equals, and we will have the square root of, we'll do 30 times, and it doesn't matter what side you call A, B, or C. So I'm going to do 30 minus 10 times 30 minus 26 and times 30 minus 24. So that means we'll have A equals the square root of 30 times 20 times 4 times 6. And if we do 30 times 20 times 4 times 6 is 24, we get the square root of 14,400, and that equals 120. So the area is 120 units squared. All right, now our last one. There is a mistake on your paper. It's 15, 16, and then this is not, the length is not 1, it won't work, but we're going to make it 10. So fix that on your paper. And the first thing we'll do is find S, which will be 15 plus 16 plus 10 divided by 2. And that is going to be 41 divided by 2. So we're going to get 20.5. And you can have a decimal there. So we'll do A equals 20.5 times 20.5 minus 15. 20.5 minus 16, and I'm going to have to scrunch it in, 20.5 minus 10. So 10 there. All right, so we get A equals 20.5 times 5.5 4.5 and 10.5. So when we multiply it together, 20.5 times 5.5 times 4.5 times 10.5 equals the square root of 5,327.4375. And we'll take the square root of that. And we get 72, and I'm going to round it to the nearest thousandth. So it'll be 989. And it'll be units squared because it is area.